I didn't expect so many people, actually. You know, Sunday morning, raining, testing. Yeah, but I'm so glad about that because, yeah, it's a kind of very not popular topic. So I'm Iggy. I work at Telnix as a software engineer in the backend side. So we use microservices, and for most of them, we use Python. So that's why. Probably you already hear about Telnix. We do a lot of stuff in terms of telecommunications. We provide a lot of different services, and you can use it pretty much all of them from your own applications using our either APIs or SDKs and all that. So I just encourage you to try to open an account. It's for free. Even you can ask for the first wireless, so the SIM cards for free, the first one, and you can try some of your stuff. This is a brief agenda for today, introduction, just to get some context on that, and then some questions about, you know, why, what, and that's kind of stuff about testing, and some conclusions, and if we have enough time, some questions, and if I know the answers, I'll be glad to do it. Context, so testing, right, as I mentioned, is not maybe the more popular guy in the neighborhood. For some reason, it seems that it's not very, I don't know, maybe creative. It's something that we have to do, but maybe we don't really want to do. And testing is one of these fields that it grows a lot in the last years. There's literally dozens of different types of testing. Each one has their own purpose, their own goal, their own target, or their own problem to try to solve. I'll just pick that two, the unit testing and integration testing, as a developer toolbox, let's say. So are these two guys that can help me to do my job probably better, to ensure that what I'm doing makes sense, or it's fulfilling what it's supposed I have to do, right? So I'll just pick that two, just because of that, it's impossible to cover the entire thing. Why do we test? I'm not trying to sell anything. I would like to know that all of you are doing really nice testing and nice coverage and all that stuff. I just want to share with you my top five reasons why I think that testing helps me to do my job better, to write better code, and so on. The first one probably is the canonical one. Probably 9 out of 10 people would say the same. I say 9 because there is always one strange guy, right? But let's say, yeah, it's a canonical one. Is that a tool that helps us to detect or to find bugs, mistakes, which are not exactly the same, but at the end of the day, is something that we don't want in our code. So, right, we detect something it's failing, and I can say, okay, it's solved. Prove me that it's solved. That is the fact of the testing. The testing proves that this bug or this mistake is not already there. I can run it, I can prove it. I cannot just have to do again all the clicks here and there to see that if it's working or not. So this is it's the most common one, but there is another ones. For example, regression, and I mean, you know, regression testing is another discipline. Regression in the sense of the code changes. It's like an organism that evolves and changes, and we add some features here, we remove some features there, we just change some requirements. And the only way to know in an automated way that we are not breaking anything that was already there working is a kind of automated test. You need an integration. So, okay, from now, when I talk about testing, it's just that two guys, okay? So this helps me to just, in a fast way, to detect that everything is in place. I'm not breaking anything, I can just keep going. Another one, documentation. That is I like that one. It's because, you know, documentation, the best scenario, and is what the books that the Bible say, is that the code should be self-explained, even no comments there, you just read the code and it's perfectly understandable. But we know that this is not always possible. This is not always, you know, the way to do that. So sometimes we need some other context, some other information, additional information that helps us to understand what this code tries to solve. And there are different strategies. There are doc strings. We have as well README files. We have as well Confluence, Sphinx, you name it. But what's the problem here always is that, as we mentioned, the code really changes really fast, very often, so you have to maintain it up to date. And that is, it's not always possible, it's not always done. So the point is, documentation that is not up to date becomes just useless because it's not true. So tests could be a good point or good place to put some information there. Let's say how a class is instantiated, how many flavors, what exceptions it raises, and all that. If the tests are passing, it means that are up to date. This is real. This is what our code are explaining. So when you just tackle some new library, new tool, or new module, if you go to the test, you can have a kind of context. So documentation is a good point for that. Design as well. And design, I mean design this kind of whiteboarding. You put some boxes here, arrows. You think how the data flow should go. And if you think in testing at that stage as well, you can detect some smell detector, right? So if some of the boxes that you put it in the whiteboard becomes really tricky to test, maybe it's doing something that shouldn't be there. Here there is something that, the code that is easier to test not necessarily means better code, but they share a lot of principles. So if it's tricky to test something, it's either because it does a lot of things, because it has a lot of side effects, or it does many things. And this is a kind of smell detector as well for our code. So at the stage of design, if you think in how testable is one piece and makes sense, I would say that this is a kind of tool even to design better our models. And last but not the least, this is an industry, we talk about money. So in terms of bugs, to detect it, there is the sooner, the better, but the cheaper as well. There's this kind of studies already done. There's something that's called the Boehm's curve that explains that it's very common sense that if you detect some inconsistency when you write the requirements, it's quite easy to solve. Just think a little bit more. Maybe after lunch you can solve it. But if you detect that solve in production, this is another story. There's a custom impact. You have to stop some team to work on that, write a hotfix. This is much, much expensive. So testing in all the stages helps us to detect as soon as possible that things because it's cheaper. Talking about unit and iteration testing probably is in depth in the development stage where we can find and solve as many problems as possible. So, okay, what do we test? We mentioned that every kind of testing or test has their own purpose or their own problem that tries to solve. So let's see that two guys, unit and integration, what they try to solve. And the first is a perfect scenario. Is the unit testing is that kind of self-contained black box. I call it SUIT because it stands for System Under Test. It's one of that fancy naming that they put it in the Bibles, right? So, and here it's quite easy. We put some A, we check some B. That's all. And here it's a very free field to try everything in A, all edge cases, all unexpected thing, and check that our piece does what it's supposed to do. Here the point is that obviously this has to be isolated. This is pretty much a scenario of what they call it is the pure functions. If we talk about functions, or could be class, but self-contained. There is no networking, there is no database interaction, there is no file system interaction, there is nothing else than what that guy is inside. So this is the best scenario, but we know that it's not always possible to do that. This checks just the different units, but this doesn't mean that entire workflow of the data works, or even that our program does what it's supposed to do. And for that reason, we have the other guy. The other guy is the integration testing. Here I'm putting this word, the broad one. This comes from an article from Martin Fowler explaining that difference between the concept, the two flavors about integration, that one is broad, the other is the narrow, that we will see in a minute. That the broad is the more as well. The more common one is the one that you put in your pipeline just when you deploy, and eventually even though that is the guy that we are testing, that guy could talk with another guy, which probably eventually could put something into the database. So in order to run all that suite of tests, you need to create a database. After every test, just remove the thing. So it's a kind of expensive thing. Run it one quite complex integration testing for one service can take maybe minutes, couple minutes, 3 minutes, 5 minutes. This is not something that you want to run after every change, right? So that is one side of the entire spectrum that we have. The other here, sorry, we are more limited in terms of test cases. So you just have the A and you have one D. If eventually D is not what you expect, maybe it's not in the suite, the problem, maybe it's in that other guy, or in another. So it's good to know this red flag that something fails, but then you have to, okay, let's find it, why it's failing, and can be in wherever the place on the entire. We have the second flavor, which is something interesting. I like that approach, that it's the narrow integration testing, and the purpose of that guy is just test the interaction, so the interfaces that you are talking with the other guys. Here is where we start to mocking and monkey patch thing. By definition, this is an anti-pattern, so if you have to create one test of that and you need 5, 10, 20 monkey patch, okay, something's wrong here. You need, again, to find another way. But mocking that guy here allows us a lot of potential in terms of we can check every piece of that, not just the A, but I can check then that the B is what I expect. C is another input, so I can try again all the edge cases, exceptions. What happened if I put this? How my system behaves after that. And finally, I have my D there. So that's the point. Where do we test? It's where, could be when, but thinking in all the workflow of a development process. So in what part you say, okay, let's do tests. And there is majorly 3 approach. This is the most common one, probably, or the one that I saw more often. Let's say we have one requirement, then we design in order to fulfill the requirements, happy days. Then we write some code in order to fulfill the design, and then we write some code to fulfill some tests to fulfill some code. And here there is something wrong here, right? Because we actually write tests with a mindset of the output. So we just, what returns, I'm checking that return. That's all. Even we don't have an idea, or I'm 100% sure that our code is doing what it's supposed to do. Just we are checking the code that is already there. Anyway, we try to test to pass a test. If eventually they fail, probably maybe could be some test that I just forgot one field in the payload, and then okay, now it's working, or not. You read the test and say, no, this makes sense. Something is wrong in my code. Where, again, you have to go and find it. Potentially it's well separated, but maybe not. This doesn't enforce that kind of approach. Once pass some refactoring, that it means do it, some renaming, make your code beautiful, right? Nice to read, blah, blah. Once you know that it's working. It's working. Second approach, it's called test first development. And this is just pretty much the same, but it's just one small but interesting change. We have some requirements. We have some design in order to fulfill the requirements. We write some tests in order to fulfill the design, and after that we write the code to fulfill the tests. Right? It's just a small one, but I think it's very powerful. And at the process of writing tests, maybe it's what we mentioned. Maybe you realize the design can be just adapted. So it's a kind of process of iterations. If we do that as more, first we agree that iterations, it means improvement. So as much iterations as possible, more improvement. So smaller iterations means major, improvements more often. so that it's like it looks like. I don't want to go much deeper. I think the idea it's pretty clear. The rest of that is exactly the same. And our friend here, the task-driven development, that it's a kind of the same approach, but even with some tweaks here. If you see, there is no design in the process, but this doesn't mean there is no design as such, but it's understand the idea that even the design evolves. The design, you cannot just have a full overview beforehand about the entire system, because probably you are mistaking something or missing some important stuff that will appear when you are working on that. So the point of that is make really short iterations in your code in order that even the design is finding the place and accommodating to the entire thing. No much to say here. I think that everyone knows TDD is quite popular or not. I don't know if it's love-hate relationship with that guy. And let's see just that, the moment of truth. I don't want to put a lot of code here because I feel that sometimes a lot of code in talks is like, okay, it's lack of context, it's really difficult to find. So I just will provide one use case, and probably it's one exaggerated one, but I think this to get the idea could be valid. Some requirements here. Let's say I have to add one endpoint to purchase some items. Obviously, assuming that we already have an application, we already have all that, authentication stuff, the users, workflow, all that, it's in place. We just want to implement a new endpoint for that thing. Here we have some requirements. Let's say I have to be able to do that and those and blah blah, all the other stuff. Let's see how it looks like. Could be something like this. So we have client that eventually will ask for an order. Then we validate the order. In the requirements, there is this kind of, okay, allowed to use promo codes or whatever. So it means that potentially have to do some business logic here. A promo code can be something that can be, I don't know, used just once or in a range of time or just applicable in some items. So probably I will have to ask other people, other services, what's going on with that one. So the validate order can be quite complex in terms of interaction with the external world. And then depending on that thing, so I can approve or revoke it, and then send a notification to the guy. So here there is basically some interactivity between the outside and the inside, right? So the red ones would be potential places where I'm talking to the external world. So I'm talking to another services, or in the first case, it's just the inputs of the external world, right? So that is a kind of something, and the other is the orange, green, yellow, orange. I think it's orange. That checks the interaction between my application itself inside, how the modules or how the different classes, functions talks between them. So I have some kind of picture because if you take a look, actually the business logic here, there is no actually big stuff. It just get something, validate it, all is okay, go ahead. Just come the first layer, there's no much to do. This is another point of view from the same. What I want is when I do the order, I just respond, okay, we are on it. I don't want to wait until all that, right? So it will be kind of asynchronous stuff. I just send the order, I say, we are on it, and then I make all the stuff. And can be a lot of them, right? Checking here, checking there, you have enough funds, or the credit card still works, blah, 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 there is something. And at the end, if it works or not, I just send a notification again saying, we accepted your order, we are working on it, or the other side, that can be no. For some reason, there is a failure, whatever. And here, all that layer is all the interaction that we need to check. And this is where the compliance, but in the APIs between the different guys have to be validated. I want to be sure that I'm sending the correct payload to the other guys, and I'm receiving the correct payload from the other guys, or I'm validating it at some point. Code. Let's see. This is, as mentioned, is a kind of exaggerated case, but can be, I think, understandable. So this is the first layer, the handler. right? So this is a kind of, this is done by the AIOSTTP, nice word, AIOSTTP. And it's about just, the payload. We receive the payload. It works in that way. It's a coroutine, so we await the JSON payload. Then this could be a kind of adapter. So whatever is the payload, we convert into whatever we want. Could be an instance, could be just another name tuple or a dictionary, whatever you want. Then we get the loop thing because we want to just send it in a synchronous way. We don't want to block here, right? And then eventually we return the JSON response, or if the validation takes some error, so we provide some error. Okay, so the way to test that, the controllers or the first line of the front is always some tricky to test because it's, as we mentioned, there is some kind of side effects, there's some kind of interaction with some other layer but we need to know that our flow, it's okay, and that guy does. And that guy pretty much does a couple of things, right? So validate the payloads and send it to the purchase order, whatever it is. Exaggerated case. As you can see, the test has more lines than the code. This doesn't bother me, as long as it does what it has to do. Quick view here. So we first set the doubles. This is just another terminology from the Bibles that they say that we call mock pretty much to everything, but actually depending on the role that it does, it's not the same if you just create an instance of a mock to fulfill the signature. This is something that you will not use that. It's just something has to be there. They call it dummy. There is the stub. This is when you provide some output. When someone asks you, you return that value, the stub guys. But there is the spice, there is a fake, there is a lot of different stuff. So here's where we configure our mocking stuff, right? So to do this is kind of weird stuff. This is the line 6, but this is in order to emulate the JSON payload from the AIHTTP. We need to do some tricky thing like this. So we're creating a mock which the JSON will return a coroutine mock. This coroutine mock, it's from the coroutine, async test, I think is the name of the library. It's for that use cases, I think it's okay. The rest is in PyTest. I don't want to go really deep in what testing framework. I think that pretty much all of them provide some nice tooling to do that. In that case, when we are injecting loop and mocker, the fixtures already are from the built-in PySync stuff. So just that, we set the payload, then we set we are monkey patching that guy, the payload to order, and here we don't care about we are providing it. Here it's a string, the stop order, line 9 is a string, but could be wherever you want. Here we are not validating the implementation, just the flow of the methods, let's say. The same for the next part. So we are mocking that one, and at the end, we are checking all the things. So we are checking that we are calling the stop adapter with the payload. We are asserting that we are using the stop purchase with the stop order, and we are checking that we are creating the task that one with that guy. This is the line 3 that is a kind of as well tricky thing. But that guy does the job. So you guarantee that the first line is doing all the A, B, C, D steps, which I think it's quite nice in terms of its isolation. That guy can run without duplication. You don't need to run anything else. You have all. And then you can create another use cases if you want. This is a failing, which is shorter. It's just when the payload fails. But it's OK. It's up to you to create other to cover. So conclusions about that. It's OK. With some caveats, but I would say that the testing, it's code as well. It's code. So should follow the best practices as well as the rest of the code. So some of that, and you name it, wherever. It's true, by the way, that we have some more flexibility. We can do less strict in some cases. We experienced some issues with the, we use SonarQube for all the quality code. And in some cases, yeah, the duplication in tests, right? But it's not duplication in the terms of copy paste. It's just because the use case looks very, very similar to another use case, but I want to keep it separate. I don't want to be related between them. So in test, sometimes I don't think that makes much sense to do abstractions and abstractions. I want to be really, really there, be able to change something, separate it, some that. So some small flavors are different, but the most of the cases, I think that testing it's code. So it's just the other side of the same thing. We have the source code, we have the test code. Probably if some feature appears or we change some feature, we will need to change the source code and the testing as well. So are both on the same level. So maintain it clean and understandable. I think that it's really worth it to that. And then just a couple of, if you didn't had the opportunity to read that tool, for me it's kind of two of the variables, of the amount of variables that we have in that field, but they are really, really interesting, and they explore all the, the caveats and the nuances about the testing, unit testing, and how to apply that, incorporate that in our development process in a daily basis thing. By the way, if you're interested or just curious about that, we have a stand there. Please come. We are hiring. You are welcome.